So 2013, my first week at Xamarin was at this conference, the Evolve 2013 Xamarin conference. It was our first ever conference. Anybody attend? I know at least one person did. Okay, there's a couple of hands. There's Dave. I remember drinking in a pub with Dave. I won't tell that story in public, but it was a good evening. So my first week at Xamarin, and I flew over to Austin for this event in order to help customers. I was a customer support engineer, and we would sit down and we would do one-to-ones. So I'd sit at the table, like Alex is here, and a customer would turn up with their laptop, and they'd be like, Mike, push a microphone. I'll do that. So the customer would turn up with their laptop, and I had no idea what I was getting myself into. It could be they've got a bug in their app, could be a bug in our code, which is unheard of, doesn't exist. Or it could be they want a code review or for me to look over their architecture. And this was my first week in the job. I mean, I felt like I was in at the deep end. You know, I had 64 colleagues to try and memorize their name, plus 700 delegates. And it was difficult to work out who was a delegate, who was a colleague. We were told to delight the developers. That was the key mantra. And it was my first ever developer conference. And I didn't pack for Texas or a developer conference. I packed as if I was going hunting. Yeah, I had long hair, and you can see I'm probably the only person that's ever traveled around Austin on a Segway wearing a barber jacket and brogues. It's not the standard developer outfit. So, you know, I dressed as if I was going for a hunt, when really, everybody else was dressed more like this. So I was a little bit embarrassed by this. It's my first week. I want to make good first impressions with all of my colleagues. So I got all the T-shirts I could get, but I needed a hoodie. So I walked around the trade show's floor, and we had a couple of booths, and Microsoft were there. And they had a couple of hoodies. So I went and I spoke very, very nicely to one of the girls, and I explained my predicament, and she kindly gave me this hoodie. It actually says Windows Azure, and I didn't think of anything of it, because I hadn't used any Azure at this point. But on reflection, Microsoft's Azure has been solving my problems from the first week of being a Xamarin employee. So Microsoft Azure really can solve your problems. But anyway, so that's enough about me. Who here has used Xamarin before? So a couple of you. Great stuff. Who's heard of Xamarin? Fantastic. So I'll cover a little bit about what is Xamarin, but we're also going to be jumping into Azure. So I want to try and keep it 50-50 as much as possible and show you some big architecture for building your Azure apps, as well as how to do really lightweight architecture as well. So a little bit of best of both worlds. So with Xamarin, we say you should be writing cross-platform code, but you shouldn't have to sacrifice the end-user experience. So you should be able to create beautifully native and highly performant applications while still sharing a minimum of 75% of your code across iOS, Android, and Windows Phone.
Can we just change your over just a second? It's not coming through.
No worries.
Thank you.
Let's just rip this off then.
Okay. Sorry about this.
It's quite fine.
Okay.
Are we live already? Perfect.
Fantastic.
Is that better? Perfect. I do shouts, to be fair, but that doesn't help you in the video, does it? So we've got 75% code reuse as a minimum. Now we're going to write our UI for each platform. So we call this a traditional style of Xamarin. So the shared C# core is anything that touches a base class library. So this is all the namespaces and in turn the classes that we know and love from .NET. And then for iOS, we're going to create our user interface using storyboards or zibs, which are Apple's proprietary formats for their user interface. So if you've built an existing application with Swift or Objective-C, we can just take those UI files and drag and drop them into Visual Studio and continue working. And then for Android, we're going to use Android XML. And again, if you've got an existing Android app that's been built with Java, We can just take that entire resource folder and drag it, drop it into Visual Studio, and you're good to go. And then lastly, if you want to target Windows, you can write XAML in the standard way. So just like when Microsoft create a new platform, say it's a HoloLens, we get some new APIs on top of the existing base class library that we all know and love. And we understand that if we learn these new APIs, then we've learned this new platform. We do exactly the same for iOS and Android. So for iOS, that base class library follows us. So all our existing code is going to run on the iPhone. And then we have a one-to-one mapping to every single API that's available to the Objective-C and Swift developers. There's not a single API that they can use that we can't access and call from C#. And the same is true for Android. So again, that base class library follows us everywhere we go with Xamarin, and then a one-to-one mapping to every single API that's available to the Java developers. So we're not limited in terms of what we can do to create our mobile applications with Xamarin. If they can do it with Objective-C, Swift, or Java, we can do it with Xamarin. So it's the best of both worlds. We get a highly performant application, so it's incredibly fast. It has a native user interface. This isn't our version of what a button should look like on iOS. This isn't our interpretation of how a map view should look on Android. It's just the native types. So I'm going to show you the world's most simple demo. We're going to basically create a hello world in Xamarin Studio, which is kind of like Visual Studio for Mac, a little bit. So you can see how all of this works. So I'm going to share my screen with you. He says. Here we go. Perfect. That's for later. So we have Xamarin Studio. If you're unsure of the difference between Xamarin Studio and Visual Studio for Mac, Visual Studio for Mac is a fork of Xamarin Studio where we're adding more code from Visual Studio PC. Now it's in preview at the moment, and I do like to live dangerously, but not in front of this many people. So I'm not going to be demoing too much with Visual Studio for Mac today. We'll be mostly using Xamarin Studio. So we're going to create a new solution, and it's worth noting everything you see me do here in Xamarin Studio works the same in Visual Studio on PC. So there's no limitations for creating iOS applications on the PC. It works exactly the same. So we're going to create an iOS app, and it's going to be a single view. As I say, this is going to be the world's simplest app. We'll call it Simple App. Boom. We're going to load up the storyboard designer. So the storyboard is Apple's proprietary format for creating user interfaces. And in fact, it's going to launch it into Xcode, which really does prove that it's the Apple format. Now, we do have an integrated designer, and I've got it by default to launch into Xcode. But if I right-click, we can go Open in iOS Designer. And then we'll launch into the integrated iOS Designer. And this is also integrated into Visual Studio. So we have the full drag and drop goodness that you would expect if you were creating your user interfaces, say, for WPF or WinForms. But we're building iOS apps, and we can do this on the PC. So we'll zoom out. We're going to go to our toolbox. We're going to add a button. And we're going to add a label. And as I say, really simple example here. So what we're going to do is we're going to click the button, and we're going to change the background color of the view, and we're going to set some text. That's it. But it's going to show you how we connect to events. And has anybody built an Objective-C or Swift app in Xcode? 2, 3, 4. Get more adventurous. I'm not going to ask anyone to come and join me. So when I ask for a show of hands, don't be too shy. I'm not going to single anyone out. Well, if you've done it in Xcode, you know about actions and outlets, which is if you double-click on a button, as a .NET developer, I expect double-click on a button to get to the code behind for the click event. In Xcode, you double-click on a button, and you can set the text for that button. If you want to get to the code behind, what you actually want to do is bring up the header file for the currently selected view controller. You want to control-click on the button, draw a blue line, drop it, because that makes sense. When you drop it, it will say, hey, is this an action or an outlet? And you'll go, what the hell is an action or an outlet? And once you've Googled it, what you actually want is an action of the touch up inside event. We were watching developers drawing blue lines for days. And we were like, there's got to be a better way, which is why we created this integrated designer from scratch. So it works how you expect. But first of all, let's set up the views. So you probably notice there is no iPhone that is a square. And that's because we're using auto layout, which is Apple's, again, proprietary way of laying out the views. So everything is connected to each other, and they don't want you to do pixel perfect design. iOS isn't pixel perfect anymore. You're designing from tiny little iPhones all the way up to iPad Pros. So your interface needs to scale correctly. So if I view this on an iPhone, we're going to see this blue is still going to hang off the side on the label. You see that? It doesn't scale properly. So let's fix that. We're going to bring up the little handlebars on the side. And we're just going to anchor to the sides of the view. Boom. We'll anchor there. And it's gone orange to say, whoa. Whoa, this is an invalid constraint. This auto layout isn't going to work. Because for every control, we're going to need to provide an X, a Y, a width, and a height. If it doesn't have those 4 values, the layout isn't going to work. So it's going to warn us within the IDE when we're connecting these, this isn't valid. When it goes blue, we're good to go. So we will set a constraint to the top. And we're going to fix a height. Now, the height can also be inferred from the font size with the UI label, but I've just gone ahead and fixed that to be a fixed height. And then for the button, we're going to drag it out across the bottom. And again, I'm going to click again to get the handlebars, and we're going to anchor to the bottom of the parent view, and then to the side, and then to this side, and then it should be a valid auto layout. So I'm going to give it a name, and we'll call it BTN button, because why not? I learned to program in WinForms, so I have a very strange naming convention when it comes to mobile development. LBL, naturally. Something. My colleagues hate me for this. So we've got this button. If we were in Xcode, we'd double-click it, and we'd be able to set the text. I'm going to double-click it. Let's see what happens. Boom. It's done for us. Works how we expect it to work. It doesn't matter the fact that this is iOS. The way that we .NET developers expect the IDE to respond, it just does it. So within here, we're going to say view, which if I hover over, you're going to see, hopefully, it's a UI view. This is a native iOS class that we're exposing within C#. And we have access to every single property and method and event that's available to the Objective-C and Swift developers. So in this case, we're going to set the background color to be UIColor.red, and we'll say LBL something.text equals hello Reading. And with that, we'll run it. And we have a breakpoint, which is perfect. So this is the standard iOS simulator. This isn't our simulator. If you're using the PC, we ship to you a simulator that you can use within Visual Studio on PC as well if you have Visual Studio Enterprise. There we go. We can see my auto layout is valid because my button is in the center of the view. And if I tap it, boom, we hit the breakpoint. Perfect. I'm just going to skip over that. And we've executed our code. So that's a really simple example just to show you debugging works how you'd expect. I could hover over those and inspect the variables and the values as you would expect. And we have access to every single API that's available to the Objective-C and Swift developers. As I say, that's all doable in Visual Studio on PC as well. So that's traditional. That's the one-to-one mapping to every single API. But a lot of the times, the views and controls that we use within mobile are the same across all 3 platforms. And we want to target iPhone and Android and maybe UWP. So if we're creating a settings page, it's going to have some toggles. It's going to be a list view, effectively. But we'll have some toggles. We'll have some labels. We may go into a bit of master detail. But it's not too advanced. The views are basically the same. But the APIs that we use to create and interact with those controls is very different across all three platforms. We can't reuse our iOS code on Android. Well, not until Xamarin Forms. So Xamarin Forms is an abstraction layer on top of this one-to-one mapping. So we found that a button on iPhone or iOS is called a UI button. And as I mentioned, its click event isn't called a click event. When you sit there with IntelliSense, which is naturally baked straight into our designer or into our IDE, you hit dot and you get a list of all the things you can do. You won't find click. You find touch up inside. But on Android and Windows, we call it click, and it's called a button. So what we've done with Xamarin Forms is we've abstracted away the differences to give you one consistent API that will run across all three platforms. So you can write your app once in Xamarin Forms, and you can run this across all three major mobile platforms without much customization. Now, when I say much customization, it's down to you to decide, what do you care about more, code reuse or design? Because if you're going for maximum code reuse, then you're just going to get the vanilla standard look and feel that we give you with Xamarin Forms, which, as you saw on iOS, that means the button's not going to have any borders, it's not going to have any color. It looks pretty vanilla. It's not that great. Now, with Xamarin Forms, we allow you to drop down into platform-specific APIs to do customization if and when you need to, but you're going to sacrifice that code reuse. So it's a bit of a weighing game to decide which you want, but we've got samples that go into great detail on Xamarin Forms. And most of our customers today, when they build brand new apps, are starting with Xamarin Forms. When we look at our tooling, we're mostly focused around Xamarin Forms as well. But naturally, we can't sacrifice this traditional style because we're built on top of it. So if you want to go with that traditional style, which is how I build all of my apps, then we've got you supported for the foreseeable. So when we look at the anatomy of a mobile app, we can see the things that the users expect. They want a native user interface. They want the native performance. And they want native APIs, which is kind of, tied in with that native UI and native performance, and they want a great design. But what they'll also want, and what becomes difficult to provide, is personalization. So making sure that the data they see is relevant to them. Searchable. Well, how do you search within your app? Yeah, you could create a link query to go and search through some data that you've got stored on the device. Alternatively, you can leverage the cloud and use something like Elasticsearch or Azure Search, and you can go and index your SQL database or your DocumentDB or your MongoDB, and you can make that available to people with predictive searching. And you can do radius searching for locations. You can build very powerful solutions. And then we've got authenticated. So authenticating your user can be incredibly difficult. And I often speak with customers that have rolled their own authentication system, and my advice would be just don't do it. It's really difficult to get right, and you don't want to be the next headline for being a big business that lost a lot of customer data because you built your own auth system. There are numerous services, and we'll talk about those a little later. But these are kind of the standard features that you're going to want in most mobile applications to some degree. So what is Azure? Well, Azure is Microsoft's cloud platform, enabling our customers and partners to reduce costs by migrating workloads and innovate faster by leveraging a cloud-first platform. I mean, that's long. And it doesn't actually explain what Azure is, because Azure is really difficult to put down into one sentence. If we think of Azure as kind of like pizza as a service, there's a couple of options that are available to us. We have the homemade pizza. We're going to grow our tomatoes. We're going to get some cows and we're going to milk them, and we're going to wait for ages and turn that into cheese so that we can grate it and put it on our lovely homemade pizza. We're going to provide the oven. We're literally providing everything required to make this pizza. It's a long, lengthy process, but we have control. We have control over everything. It's great. Then you have the cooperative. So this is where you might still be making the pizza yourself, but you're going to go and get the dough from the shops, and you're going to buy some tomato sauce. You may buy some pre-made cheese. Alternatively, you may go to the pre-made pizza section in the shop and just buy one in a box and throw it in the oven that you still provide. You're still providing the table and the drinks and everything else, but the pizza, someone else has made that. Then you've got Domino's, which is where you can just call out and someone's going to bring a pizza to you. All you need to provide is the dining table and the drinks, and you're good to go. And then lastly, you've got the restaurant, which is where it's all provided for you. So if we start with homemade, that's going to be on-premise. Then we have the cooperative, which is infrastructure as a service. Then we have Domino's, which is platform as a service. And lastly, Jamie's, or the restaurant, which is software as a service. So if we look at the balance of responsibilities about what would you need to manage versus what will Microsoft manage for you, you can see that for me, platform as a service is the place to be. I can focus on what's important to me, which is my data and the app, rather than all of the bits that surround it. So I don't want to worry about updating virtual machines. And I don't want to have to worry about any infrastructure. I just want to have an app that's running in the cloud that can scale up and down when it needs to. So we're going to be focused mostly on platform as a service today. But it's worth noting, with Azure, because it's so flexible, it is possible to have platform as a service, but where you're going to be calling into different parts. If you've got an on-premise server, we can connect straight to it. We can create a hybrid cloud. So if you've got data in a legacy system that you're worried about, how do I get this into Azure? Maybe you don't need to bring it into Azure. You can leave it where it is, and we can just connect to it from Azure. So we can really create exactly what we need to solve the problem. We're not forcing you to move or migrate everything into the cloud if you don't want or need to. In fact, we can even take this platform as a service, app service, and we can run it on-premise if you really want to. It's not cheap, but it's doable. So when we talk about app service, there's a couple of kind of sub-products. I like to think of app service as an umbrella term, because again, it's not the easiest thing to explain. Because when someone says, well, what is app service? You go, well, it's a way to host your backend, but you can build your backend in Node, so you can use JavaScript if you want, or you can use ASP.NET. You decide. And they go, well, how do I store my data? And you go, well, you could use NoSQL, or you could use SQL. And if we're going with NoSQL, it could be MongoDB, or it could be DocumentDB. And I'll show you this in the next slide. There's a lot of options that are available to you. But if we're within Visual Studio and we do File, New Solution, and you want to create an app service, you're going to get a couple of options. Oh, let's just pop back. Here we go. So we've got the web apps. We have mobile apps, logic app, and API apps. Now, these are just standard ASP.NET projects, which pull in different NuGet packages depending on which project you select. You are not limited. If you just do File, New Solution, and create a mobile app, you're not just limited to the mobile set of APIs. If you want to add Razor views to create UI views, you can go ahead and add the NuGet packages that are available within the web app. So again, very customizable. We're not limiting you to just what we give you. You can extend this however you would like. And it really is a truly bespoke backend. So I created this slide yesterday, and I was going through just some of the services that I've been dealing with customers recently and what they've been using. And it's so varied, but these are the standard ones that I find across almost all of them. So if we start with data, as I say, we can use Azure SQL. So who's experienced with SQL Server? It doesn't have to be Azure SQL, but SQL in general. Most people. So you can take that experience that you already have, and you can apply that to SQL Server in the cloud. So all your mappings of objects and relationships between them, you already get how that works, and you can plug that straight into Azure App Service. Who's used NoSQL before? Significantly less people. Interesting. I'm a big fan of NoSQL. We have support for DocumentDB or MongoDB. If you've got a MongoDB or a Mongo database, I don't want to say MongoDB database because that's just crazy. If you've got MongoDB, you can actually just point straight to DocumentDB, and we've got API compatibility with the drivers. So you can store your data in two places at once if you want to without having to modify much code on your end. So as well as that, we have authentication, so you can do social auth extremely easily with App Service. You can do it with Facebook, Twitter, Microsoft, and Google. And on top of that, we have Active Directory, and we can do custom authentication. So has anybody here rolled their own authentication system? 1, 2, 3. Hands slightly up, I saw over there. Yeah, I would be worried as well. If you do have your own custom authentication system, you can integrate that in with Azure. You're not locked out. We will always try and sell you onto Active Directory, though, so apologies if you phone and ask how to do that. We have push notifications, so we can send push notifications to iOS, Android, and Windows devices. And then we have intelligence. So we can use Hadoop, so we can build clusters for machine learning. We can use machine learning as a service from Microsoft, or if we're going for the software as a service, we can use cognitive services, which are just REST APIs that are backed by years of research within Microsoft about learning, about vision, about sound, or analyzing sound. There's so many APIs within cognitive services. It's 21 different products that sit within this subcategory, and it can really add intelligence to your application. I've been building a beer app for a while, and I wanted to build recommendations. And when I started the beer application, I was throwing all the data that I was collecting into the SQL database, and I was going, at some point, I'm going to have to learn machine learning to be able to build a recommendation engine. It's not my expertise by any stretch of the imagination. And I've waited long enough that it's become part of a service within cognitive services. It's just a REST API. Anytime someone checks in a beer, I can send up a little message to cognitive services telling them the beer I've checked in. Once I get to 1.5 million check-ins, I will have enough data, because it is big data. Big data is really just a lot of data. Once I've got 1.5 million check-ins of beers, I'll be able to make recommendations from just the REST API. The machine has taught itself from people that are vastly more intelligent than me. So it's a really great way to add intelligence to your app, even if you lack the intelligence, like myself. So we're sharing our code from iOS, Android, and Windows. But with Azure, if we're going with ASP.NET and we've chosen C#, we can even share our code onto the back end. So at the minimum, we should be able to share our data objects between client and cloud. And I'm going to show you, it's a pretty advanced example of Azure and Xamarin. It's called the MyDriving app. Has anybody seen this before? Perfect. 1. But you work for us, so that doesn't count. So this is an app that myself, Piers Bogan, and James Montemagno created. So it was just before the acquisition. So it was before it was announced that we were being bought by Microsoft. We were told that there was an important project that we needed to build for Microsoft, and that they're going to demo it at Build. And they sent over the design to us, and it was quite clearly built by someone that had never looked at an iPhone or an Android device. It had UWP written all over it. So the first thing I did was I got rid of the design, and I did File New in Sketch. I created something equally as ugly, and then we decided to just steal the design from one of my other apps, which is the beer drinking one. But I was responsible for building the iOS app. Piers did iOS and Android, and James did just the Android version. And we got this built within about 6 weeks. And the whole time we didn't have a backend to connect to, and I'll talk about that in a moment. But I have a nice little video. Hopefully it's not going to be too loud.
So often developers really don't know where to get started to build their first mobile or IoT application.
You're dealing with a lot of moving parts, and so from my perspective, I love the idea of making that space really easy for developers.
We created the MyDriving app so that developers could see a sample application that would allow them to build those kinds of apps. The MyDriving app is a rich mobile experience, a real example of how you might take IoT sensor information from your car, combine it with sensor information from a mobile device, and basically build a stream of your driving habits that we then send to the cloud and aggregate it with not just your driving habits, but other users' driving habits, so that you can get stats on, are you a good driver or not, or your trip history. You can have map information as you drive, which updates in real time, and you can also replay those trips going forward and back. We built the iOS and Android apps using Xamarin, and all of the sensor information was being sent up to the Azure IoT Hub.
That hub is all about getting it to the other backend technologies such as Power BI, Azure Stream Analytics, Azure Machine Learning, just to name a few.
You can really easily build an app that can go to multiple platforms, be it iOS, Android, or Windows. We spent a lot of time thinking about the architecture. We really wanted to make sure that we got a high degree of code sharing across the different mobile apps. We also wanted to make sure that we had a really great native look and feel, and then make sure that the app would scale when it's deployed into the wild. To me, the most exciting thing about this app is that it's a great learning tool. If you just download the source and you start poking around in it, you'll see how easy it is to build a mobile app or an IoT-based solution.
So, as I say, we had 6 weeks to build the mobile app for that, and we had no backend. We had no OBD connectors when we started, and we were just told, oh, yeah, you plug this device into a car. I don't drive to start with, so the idea of OBD is mind-blowing. But OBD is when you break down, and the RAC or the AA, they come, and they plug in a machine into your car. They're plugging into the OBD port, and it gives you diagnostic information. So we had to effectively communicate with these random Bluetooth devices, take the information and then stream that up to IoT Hub. So it was an app in 2 halves. We had this IoT functionality, which was just streaming the data straight up when we could. And then we also had the trip information and how you information about how you are as a driver, so your fuel consumption. We also added in the ability to do things like take photos along the way, but we actually pulled that from the video. But all the code is there if you want to have a look. So let's jump into the code. Oh, we got an error. Oh, that's not a problem. So I'm going to talk through the architecture for this application. So this is all available on GitHub, so you can go ahead and download this and play with this. This is what I like to describe as the enterprise-grade architecture for Xamarin applications. This is an architecture that we've kind of evolved over the last 18 months to 24 months, working closely with the .NET team at Microsoft, working closely with some of our best engineers within Xamarin. So if you're looking for a great proven architecture for building Azure connected applications, this is a great place to start. It's not the easiest of things to get started with if someone doesn't show you around it. So let's show you around. There are projects for days. We have our application, so our... How long were you going to sit there in silence? Nobody said a thing. Let's have a look. Here we go. That should hopefully switch over. There we go. Can't believe you sat in silence for that long. I should have tested you and just carried on. So we have our project. This is Visual Studio for Mac. You see, it looks very similar to Xamarin Studio. It's almost like I just changed the theme in this example. So we have our storyboard, which is part of our iOS project. And we have our Android project. So this is the traditional style. It's a one-to-one mapping, but we wanted to maximize code reuse. So within our view controllers on iOS or our activities on Android, they're just really thin layers that are calling into shared code that lives within a portable class library. Now we wanted to have offline sync with this app because when you're driving around, you don't have the guarantee that you're always going to be connected to the internet. So if you're offline, we're just going to store it on a local SQLite database. And when you get connected again, we're going to sync that up to the cloud, and we're going to pull down any information that we don't already have in our local database. So we have full offline support, and I'll show you how we've done that as well. But the main thing with this application is to start with probably the data stores. So when I talk about enterprise-grade architecture, it's about the ability to easily test this and add new features. And to easily test and add new features, it needs to be a very modular architecture, so we can swap things out as and when we need. So we use a service locator, which is, mixed reviews within the community whether or not that's the right approach. But within this situation, we use a service locator to swap out implementations. So you'll see that we have our abstractions, which is just our interfaces for our different stores. And if we look in here, you're going to see that we have our iTrip store, for example, or our iUser store, which we're going to implement across our Azure and mock data stores. So the mock data store is the first thing we built because we didn't have the backend to actually call up to Azure, but we needed to carry on and create our user interface. We only had 6 weeks. There was no time to sit around and wait for people to build the backend. So we created mock data, and we used the service locators to provide that within our views. So if we come in and have a look at like the trip, you can see that we've just got loads of dummy data. And this is a pretty neat way to get up and running with your mobile app quickly. If you use that service locator, when you have the backend available to you, you can just come in and implement the datastore.azure, making sure that you've got the interfaces for each class, and then you just go ahead and implement that. Now, the stores sit around this concept of base stores. This is our table storage, so when we're calling up to the web app on the back end, it's going to be using Entity Framework and it's going to be using SQL database. So that's how we're storing everything. So we've got this concept of tables. So we're storing, in this case, it's a trip. So we can save that to our local SQLite database, and then that's going to sync up to Azure. But to do that easily, it's a couple of lines of code, to be honest with you. To do that robustly, a couple of 100 lines of code, because you can't just call into the API. You're going to need some level of abstraction. And that's what most of this code is. It's just levels of abstraction. So if we come all the way up to the top, we can see we have this iMobile Service Sync table. This is using generic, so we can pass in any type. So in this case, we'd pass in a trip or a photo or the user. And then we have access to the CRUD operations for that table. So we want to insert, we want to delete, we want to sync back to the cloud as well. And as I mentioned, we want to be able to share our data objects as a minimum. So if we come into data objects, every data object inherits from this base data object. If we have a look at what's happening in the base data object, you're going to see that I have this if-def. If I'm on the back end, then we're going to inherit from entity data, which is a class within Entity Framework. Now, naturally, I don't want the full Entity Framework on my mobile device because that would be madness. I don't need it. I just need a couple of classes or properties within my class in order to get offline sync to work. So we can share our code in this way with the if-def on the back end. Then if we come into the Azure client, you can see that this is where we create our Azure Mobile Service Client. And all of these classes, the iMobile Sync Table class, that's coming from the Azure Client SDK, which is available on NuGet. Now, there's 2 SDKs that you can download. One has SQLite in the name, the other doesn't. If you want offline sync, you need that SQLite version. If you don't have it, it's an online-only application. Now, you may be thinking that my users are always going to be connected to the internet. You know, they may live in London, for example, so they should always be connected. But it's not just about being always online. It's about the speed in which we read and write data. The fact that when I want to save something, I can save it to my local device, into the local database, very, very quick. And then I can sync it at a time that's convenient. So I can build rules about only syncing when I'm on Wi-Fi. Don't want to sync when I'm on 3G. I've got a lot of data. Or when I want to fetch data, rather than scrolling through the list and having to constantly be calling out to this remote web service, I can just be asking the local SQLite database to feed that information to me. So it's a significant speed increase through using offline sync. So it's well worth using, even if you don't envisage your app going offline. You get a huge performance increase through having that local SQLite database on the device. So we have all these abstractions for the things like the data stores. Then we have this MyDriving project. Now, this is a portable class library, and this contains our view models. Now, we're not really using MVVM, because Android and iOS is MVC. Everyone know what MVVM is? A couple of you don't. Everyone know what MVC is? Just MVVM's like MVCs, more V's and M's, less C's. You've got it. So we have our view models, and our view models are doing all of the real work. This is where the grunt of the application is happening, but it's only affecting the base class library, or it's only interacting with the base class library. So we can share this across all 3 platforms. And then our views, the activities and the view controllers for iOS and Android become very, very thin layers just to connect the UI up to these portable class libraries. So if we jump into one of the views, we're going to screens. I'm just going to pick one at random. We'll do login view controller. We've got some errors. No idea why. This is preview. This is why I don't use Visual Studio at the moment for the Mac. But we can see that we're going to be calling into, here we go, view model, execute, login with Twitter command. So we're calling into that shared code. So it's a very, very thin layer of code that I need to write that's going to only be unique to iOS and Android. Now, we could have built this app using Xamarin Forms, but you probably saw in the video there's a lot of customized UI in terms of that map view. And that would have been a real pain to do with Xamarin Forms, because that customization level adds a little bit more complexity when you're doing Xamarin Forms. When you're doing traditional style like this, where you've got that one-to-one mapping, it's very, very easy to do, and you can still achieve a huge amount of code reuse if you use this style of architecture. So that's available for you to download from GitHub. And I won't bother with mirroring the screens for this section. So I've been building Azure apps for a little while now. And I've found that with each app, we've been going back to this reference architecture, and I've been copying and pasting large chunks of it. I've been saying, right, I need that class. I need that base table class. Absolutely have to have it. I'm going to need a service locator. And I'm pulling in, or copying and pasting all of this code and changing the namespace, and it just seemed a little bit crazy to me. I was like, I should probably package this up into a library that I can put on NuGet and just reuse in all of my applications. So Piers Bogan and I decided that that was a worthwhile pursuit. So we created app service helpers. So it's a lot of the code within app service helpers is code that we developed from the MyDriving application, but it's more reusable and more generic for you. So it allows you to add offline functionality to your Xamarin or .NET application with just 4 lines of code. And you saw I was going through multiple classes, hundreds of lines of code to get offline sync to work. None of it seemed particularly intuitive. There's lots of error checking. It's boilerplate code. It's not code that we want to write. We want to solve real problems. We don't want to have to worry about error checking or conflict handling or anything like that. We just want it to work. And that's what App Service Helpers is designed to do. So it's built on top of the standard Azure SDK for .NET developers. Now it's built on that SQL-Lite NuGet package. So offline sync is integral to App Service Helpers. If you want to do online only, you're going to have to fork the library and create your own version. It's entirely possible. All you would change is that I sync table to just an I table. You drop the sync word from it, and it's now an online only table. So we're built on top. Because we're built on top, you can drop down into the standard APIs that are available to you within the standard SDK. It's not some high-level abstraction that you're stuck to. When you need to get access, you have access. It's modular in architecture, so you can decide which parts of App Service Helpers do you want and which don't you want. It's available on NuGet, and it's open source, so you can download it and you can help us build it if you really want to. So here's an example of all the code you need to interact with Azure with App Service Helpers. So the first thing we need to do, hopefully we can all see this, is initialize the library. So we pass in our URL, so that's going to be like my website or Mike James's sample websites.azurewebsites.net. I then register my objects. So in the MyDriving example, we had a trip store, a trip point store, and we had a user store. So I would register users, trips, and trip points. And I need to register all of my tables or my objects ahead of time. So I want to do this fairly early in the application, maybe within the app delegate, or within the main activity on Android. Once I've registered them, I'm going to need to finalize the schema, and then it's done. I can't add any more. So you really do need to do everything you're going to use, every table, every object, ahead of time, and then you're done. And once you finalize the schema, you can do cool things like create a connected observable collection. So a connected observable collection is an extension of the observable collection that is backed by Azure. So when you do CRUD operations on this, if you're online, we will send it straight up to Azure. If you're offline, we're going to save it to the local SQLite database, and when you get online, we're going to sync it back for you. So that's pretty nice. So let's, oh yeah, it's available to download today, but I want to show it to you. So how long have we got? 9 minutes, perfect. So let's pull up the project. So this is an application that didn't take me very long to build at all. And I'm always very, very nervous about showing it. And I'm even more nervous knowing that this is being filmed. This pulls in headlines from various news sources. Yeah. So if you are offended, apologies, I didn't write the headline. There's one particular tabloid in Britain where most of these come from. I won't name who. It should be fairly obvious. But the idea is to decide, is this a real headline or is this a fake headline? So it's a Tinder-style application, so you swipe real or fake, which is pretty cool. But to start with, the first version I built, because I just wanted to build the Tinder view, to be honest, because it was a nice little example of iOS animation APIs. So the first version, I just had some XML that I stored in the resources folder on iOS, and I would just deserialize that on launch, and I'd get my headlines, my data for the app. But I didn't want to have to ship an iOS App Store update every time I wanted to add or potentially remove headlines. I wanted to be able to do that in the cloud, but I didn't want to have to build an entire cloud backend for this. So I went with the easiest option, which was I created, in fact, it should be on my desktop. Wow. I created this. But I actually created it in Excel and then exported it. So I went into Excel and I created my data, and then I was able to just upload this within the Azure portal. So I wrote no lines of code for my backend. It was entirely auto-created for me using app service with easy tables. So it's just upload a spreadsheet effectively. Boom, all of my data is populated. If there's anything too offensive in there, I can go in and I can mark it as soft delete for presentations. Hopefully I've got them all. And then once we've finished, I can come in and turn those off so that when people are actually downloading it in the App Store, they can get the full-on being offended experience. So as of right now, anyone using the app that's downloaded from the App Store is getting neutered results, which is probably best. So, dun, 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 dun. Happens to the best of us. So we'll launch Xamarin Studio again. And we'll bring up Bait News. Perfect. So within this example, there's no shared code. This is all just living within the iOS project. And this is traditional, so it's a one-to-one mapping to the platform APIs. So within my, in fact, let's just run the game so that you can see it in action. And then I'll talk you through what the code is doing. So we'll hit play. Now it's downloading all of the headlines from, beautiful. It's downloading all of the headlines from Azure. It's saved those in my SQLite database. And now I can start swiping with full speed, and it's just pulling that data from the local database rather than having to reach out to Azure over and over and over. And as I said, I didn't write any code for the backend. I just wanted to put a spreadsheet up there and effectively have it sync down to devices. So I can, as I say, I built this app firstly because I just wanted to do animation. So we can just swipe off to the side. Brilliant. I mean, it's perfect. So the way that I originally built this is we kind of had headlines as just being a standard observable collection of headlines, and it was coming from helpers.dummydata.headlines. So that was effectively my app. The helpers and dummy data was just that parsing of the XML. And to get it online, all I had to do was press undo. No, I had to write a little bit of code. But I pass in my endpoint, so my new Azure backend with this data stored in easy tables, which is using SQLite and Node.js, so it can scale up and down just as much as an ASP.NET app. So if I have 1 million users all decide to come and do this, my credit card will probably bounce eventually when I get the bill, but it will scale up to meet that demand. Then I register my headline, and if we come in and look at the headline, go to declaration, you'll see that I'm inheriting from entity data. Now, as I mentioned before about entity data, I want to be able to share this object with the backend as well, but I don't want entity framework on the device. So actually, entity data class here is coming from app service helpers, and it's got all of the properties that you need in order to do offline sync with the backend. So it's, again, maximizing the code reuse through these little helper classes. So let's come back to the game. We finalize the schema. Once we finalize the schema, we can create this connected observable collection. And then we just interact with it like it's a normal observable collection of type headline. There's no fancy magic that we have to do. It's all just implemented for us. Now, we have authentication support within this, so that if you want to authenticate with Facebook or Google, you get the token. We're going to store that securely for you, and we'll deal with token refresh, which is, again, something that by default you would need to implement. We've dealt with it for you. We have the conflict handling. Again, Microsoft would expect you to do that on your own within App Service Helpers if you want. You can use our own conflict handling, and when you create the table, you can set an enum and say, actually, I want latest to take priority, or I want the cloud version to take priority, or the device version. So it's a pretty flexible library. And because it's open source, you don't have to just grab the project from NuGet and add it to your project. You can go and grab the individual classes if you want in order to add to your application. And as I say, it's built on the architecture, or the classes from our architecture, from our enterprise grade. But you can see this is not how you should build an enterprise grade application, but it's going to get you to an offline sync application with just 4 lines of code. And it's a fun game. It's in the App Store if you want to download it and play with it. The version 2 will be coming out fairly soon. I have some other example applications that you may want to check out. Beer Drinking is a social beer tracking and drinking application built with iOS and an Azure App Service backend. I'm moving that from SQL over to DocumentDB, so I'm in the process of that. If you want to have a look at DocumentDB, that's well worth checking out. It's a fantastic service. We've got My Step Counter, Dutch Spelling, and then an OS 10 application, again, built with C#. Everything I do is with C#. It's my favorite language. So Xamarin and Visual Studio is loved by developers and loved and trusted by developers. We've got a lot of customers that use this technology. So I highly recommend that you go out and you download Visual Studio 2017. We're built straight in. Give us a play. We're on the Mac, so if you're a Mac developer, you can grab Visual Studio or Xamarin Studio on the Mac, and you can use that as well. You can find me online. I've got a YouTube channel where I produce tutorials. So if you want to find out a little bit more, go in depth with particular features, jump onto my YouTube. You can find me on Twitter at mikecodes.net. You can find me on GitHub at mikecodes.net. I think you're seeing a pattern here. And you can find my blog at mikecodes.net. Thank you very much.
Okay.